Welcome to our Christmas special webinar on sealing with spout tools. My name is Tobias Hönig. I'm the product manager for cera2seal, which means this all includes our digital sealing systems. And with me is my colleague Daniel Diebold. He will support me today with our trials, what we try to show you. Okay. If you have seen our webinar in September, then you may also know or already know something about our digital sealing technologies. Today we will look at, or have a look more in deep what means this for the spout sealing. Spout sealing is a topic currently in the industry which is very fast developing. Many customers asked us for spout sealing technology after our webinar in September, and this is why we decided to make such a special webinar today to show you a little bit more in detail our spout sealing technologies. So what do we have? The spouts, there are existing spouts which are varying in the geometry, like here these round shaped spouts. Also what we have here installed in our sealing rig is such a parallelograms spouts, and you know there are many different spout geometries in the world, but the good thing is we are able to adapt on these different geometries very easily, because we have these ceramic heaters that are applied in this spout geometry in a way like that. It's a kind of a puzzle. So we are choosing, depending on the spout geometry, different kinds of these heating elements, arranging that, for example, in that way, put it all together in this geometry with a special metal alloy that is the closing for that, or the housing for the ceramic heaters, which means kind of a mechanical safety for the ceramic heaters. And with that alloy we are able to mill different surfaces, different geometries, depending on the final spout you have in your application. So we are here on our test rig. This is a test rig we use for all of our digital heating solutions. We are able to implement, for example, the spout tools, sealing bars, round or circular sealing heaters. Control this with the PC, and the spouts directly are controlled via our web interface. It's a web application which can run, for example, on a PC, on a laptop, or like here shown in a tablet PC or tablet. So, how does it work? At first you can see here in the middle a graphical solution. This means it's a digital twin of the sealing system you have in your application. You can see here the geometry of this linear flanked spout is the same like in our test rig here. So, to start a test trial where Daniel will support me, we have equipped the first pouch and the first spout in our test rig, and how easy this works I can show you now. And the first step what I will show you is how does it work with a simulated current standard tool. You know, with a standard cooling or a standard heating system, you're only able to set one temperature over the complete spout system and hoping that the sealing will work. So the first step or the first trial we will do is we will set up a homogeneous temperature of 140 degrees Celsius, which is very easy to do in this pop-up window. You can select the temperature and set it for all circuits, and then you will see if you click, for example, such a pixel here. So you see here 16 single pictures which are all independent controllable. You can set for each pixel a different temperature, for example. But now for this trial, I have set a homogeneous temperature for all the pixels. Okay, now we are reaching the 140 degrees Celsius, which you can see here in this pop-up window on the bottom left side. Now we are ready to seal our first pouch. Daniel will start this. Takes a few seconds till our system is ready. And then you can seal. Okay, so what you can see here, we have a temperature setting, and we have a quite good looking optical appearance in this foil or in this two-layer film area, and we can hope that it's tight and sealed. We will check this when Daniel fills some water in this pouch and squeeze it. And in the meantime, I will prepare another trial.
Okay, I'm going to squeeze it a little bit to see if it's tight.
And so the water's dropping out.
Yeah, it's not working.
Okay, so then we can start. Well, I think Daniel, you are better in that than I am. I'm just an office guy. Okay, so when you have this in your application, then you, for that tools, for example, a normal tool or a current tool, then you have whether the option to set a low temperature, which is good for your film area, or you have to set up a high temperature, which you are going to do now, when we are or when we will seal the spout area. So, and what happens is we set up the nominal temperature to a higher degree. For example, 160 degrees Celsius, set it, and instantaneously the system is reacting. It fires up with the heat up rate, and then you have reached this 160 degrees Celsius. So the second trial we can start. Okay. So, and if you look and compare the two pouches, I can think just from an optical point of view, if you compare these two pouches, you can see what happens with a normal tool when you set up a much higher temperature rate than it's normally used or normally which would be expected. You have in the spout area typically a quite good sealing, because the spout consumes more energy and the sealing should be tighter. We will check this. But the film area, of course, like here in this area, is much worse than the one compared with the lower temperature. So we check this with our water. So maybe we can have a good or tight seal, or I expect there is a tight seal, but we will see this in a few seconds. Yeah, of course, like expected. It's optical, it's an issue, but from a tightness point of view, it's okay. But I think the customer won't be happy with such a goal or such an effect. Yeah. So now it comes to play our cera2seal digital heating system. What we have seen up to now is just the status, what it is with the normal system or current system. With our cera2seal system, we are able to set a different temperature or different temperatures in different areas of the spouts. This is totally easy. We are going into our web surface and we are able to browse through a recipe, I would call it. We are loading such a temperature profile, and you get the message, the temperature profile has been imported. and then you can directly see how the system is reacting. So we have in the middle a higher temperature than in the rim area. So, and what this means for our sealing process, we can start the sealing and you will see it. Yeah. So, as expected, I think we should, or I would expect now, that we have a tight seal in the middle area, which we will prove through our water test, and we would have a much better optical appearance in the rim area or in the shoulder area of the pouch. Okay, as you can see, it works like it was my expectation. The middle area, the spout area, is sealed tight, and the rim area is in a good optical appearance a customer would accept, I think. So, in a comparison, you can see here again the results. I will summarize this. If you have a low temperature with a homogeneous heated sealing system, a current heated system, then you have the choice whether in a good optical appearance but no good tightness in the spout area. If you have too much temperature set it up in the system, then you will seal a tight spout, but you have an optical issue in the rim area. And with our heating system, you're able to control different zones of the tool, and you're able to get an absolutely tight and optical perfect results for the spout sealing. This is what we wanted to show you today. I hope you find it interesting. We are awaiting your requests for this technology, and yeah, the last thing I can say or we can say is we wish you a Merry Christmas and a Happy New Year. Thanks.